When people first hear that nothing can go faster than light, the instinctive reaction is to treat it like a technical problem. We imagine better engines, smarter designs, future breakthroughs. After all, history is full of limits that turned out not to be limits at all. The sound barrier fell, space was reached, computers shrank from rooms to pockets. So it feels natural to assume that light speed is just another challenge waiting for the right solution. But that assumption is exactly where the misunderstanding begins. The speed of light isn't a record to be beaten. It's not even primarily about light. It's a structural feature of reality itself. It's woven into how space and time behave. And once you see that, the question changes from why can't we go faster to something far more unsettling. What kind of universe would even allow it? Here's the strange part. Light doesn't go at its speed because it's made of light. It goes at that speed because that's the maximum rate at which cause and effect can propagate through the universe. It's the speed at which reality updates itself. If that sounds abstract, good. It should. This isn't an engineering rule. It's a rule about how events are allowed to influence one another at all. This is where Albert Einstein quietly pulled the rug out from under our everyday intuition. He showed that space and time are not rigid backdrops where things happen. They are flexible, dynamic, and responsive. And their job, whether we like it or not, is to make sure the speed of light stays the same for everyone, everywhere. Think about how absurd that is. If you chase a beam of light, common sense says you should see it slow down, but the universe refuses to cooperate. Instead of letting light behave differently, space contracts and time slows down for you. Reality itself bends to protect that one number. That should immediately tell you something profound. Light speed isn't obeying the universe is obeying light speed. Richard Feynman had a talent for cutting through the fog and getting straight to the heart of things. He didn't like mystical explanations, but he also didn't sugarcoat uncomfortable truths. And one of those truths is this: when a rule shows up everywhere in physics, without exception, it's not a coincidence, it's a clue. It's telling you how the game is fundamentally played. Light speed is one of those clues. It's the same in empty space and near stars. It doesn't care about motion, perspective, or ambition. And when you try to push against it, the cost isn't just high, it's infinite. Not very large, not impractical, but literally unbounded. That's not a technological inconvenience. That's a wall written into the equations that describe reality. Psychologically, this is deeply uncomfortable. We're used to thinking of limits as external obstacles, mountains to climb, barriers to break. But light speed is different. It's internal. It defines what motion, time, and causality even mean. Remove it, and you don't get a faster universe, you get a broken one. Effects happen before causes. Order dissolves. Meaning itself becomes unstable. So when you hear that light speed is the limit, don't imagine a cosmic speed sign flashing "Do Not Cross." Imagine something far stranger, a universe that only holds together because that limit exists at all. And maybe that's the real takeaway. Not that we are constrained by the universe, but that the universe is carefully constrained so that anything, including us, can exist within it. Once you accept that light speed isn't just a number but a structural rule, the next realization is even more disturbing. The universe doesn't enforce this rule by brute force. There's no cosmic police stopping fast objects. Instead, space and time themselves begin to fail long before the limit is ever reached. This is where Albert Einstein fundamentally changed how we understand reality. Before him, space was space, time was time, and motion happened inside them like actors on a stage. Einstein showed that this picture is backwards. Space and time are not passive. They respond. And when you try to approach the speed of light, they respond violently. As something accelerates, time does not pass at the same rate for it as it does for everything else. Its internal clock slows down. This isn't an illusion or a measurement error. The slowing is real. Atomic clocks confirm it. Particles confirm it. Nature confirms it every time we look carefully enough. Push closer to light speed, and time itself begins to freeze. At the same time, distances in the direction of motion shrink. What looks like a long journey from one perspective becomes a short one from another. Space compresses, not symbolically, but physically. The universe quietly rewrites geometry just to keep one rule intact: light speed must not be exceeded. This is the moment where intuition breaks. We want to believe that if we just add enough energy, we'll eventually get there. Faster engines, more power, better materials. But that way of thinking assumes that space and time are fixed. They aren't. The closer you get to the limit, the more the universe changes the playing field from your own perspective. Nothing feels strange. Your clock ticks normally. Your body feels fine. But to the rest of the universe, you're becoming distorted. Time for you is slowing. Your length is shrinking. The cost of going faster isn't just energy. It's reality itself. And here's the crucial point. This isn't a bug. It's a feature. The universe doesn't allow light speed to be broken because doing so would tear apart the structure that keeps events ordered. Cause must come before effect. Information must have a direction. Without that order, physics stops making sense, and so does experience. This is why relativity isn't just about motion. It's about protection. Space and time sacrifice their own stability to preserve causality. They bend, stretch, and distort so that the universe doesn't collapse into logical chaos. There's something deeply philosophical hiding in this. We tend to think of time as universal, something we all share equally. But relativity tells us that time is personal. It depends on motion. It depends on gravity. It depends on where you are and how you move. The faster you go, the less time you experience. Push that to the extreme, and time itself disappears. At light speed, time does not pass at all. That should make you pause. Light doesn't age. From its own perspective, if such a perspective could exist, it is emitted and absorbed at the same instant. No duration, no before or after. Time only exists for things that are slower than light. In other words, time is the price we pay for having mass. This reframes the speed of light completely. It's not just a limit on motion, it's the boundary between experiencing time and escaping it, between living inside the flow of cause and effect and existing outside it altogether. And that leads to an uncomfortable but powerful thought. The universe doesn't let you outrun time. No matter how fast you go, time adjusts itself to make sure you're still inside the story. So maybe the lesson here isn't about speed at all. Maybe it's about humility. The universe isn't impressed by acceleration or ambition. It responds by reminding us that reality has a structure, and understanding that structure may be far more powerful than trying to escape it. By the time you reach this point, a pattern should be emerging. The universe doesn't shout no when you approach the speed of light. It simply makes the journey more and more expensive, not in dollars or effort, but in something far more fundamental: energy. And this is where Richard Feynman offered one of his most unsettling insights, not as philosophy, but as plain, unforgiving mathematics. Feynman had a habit of stripping away comforting stories and leaving you face to face with what the equations actually say. And what they say here is brutal. The faster an object with mass moves, the more energy it takes to accelerate it further. That part sounds reasonable. We're used to diminishing returns. But relativity doesn't just give diminishing returns, it gives a divergence. As you approach the speed of light, the energy required doesn't merely increase sharply, it blows up. It goes to infinity. Not very large, not beyond our current technology. Infinite. No matter how powerful your engine is, no matter how advanced your civilization becomes, the required energy grows faster than you can supply it. You don't hit the wall because you're weak. You hit it because the wall is mathematical. Feynman loved this kind of result because it leaves no room for negotiation. Nature isn't being dramatic. It isn't enforcing a moral lesson. It's just following the rules implied by the structure of space-time. And those rules say that mass and light speed do not mix. Psychologically, this is hard to accept. We're deeply conditioned to believe that anything physical can be overcome with enough resources. History reinforces that belief. But infinity is different. Infinity is not a big number. It's a statement that the question itself is ill-posed. Asking how much energy it takes to reach T-speed is like asking how much fuel you need to reach a place that doesn't exist on the map. What makes this even stranger is that nothing special seems to happen at the brink. There's no explosion, no tearing of reality, no dramatic moment where physics panics. From the outside, you just keep pouring in energy and getting less acceleration in return. From the inside, everything feels normal. But the equations quietly refuse to cooperate. This tells us something profound about how the universe is built. Light speed isn't enforced by force. It's enforced by geometry. Energy and momentum are woven into space-time in such a way that pushing an object with mass to light speed would require rewriting the universe's accounting system, and the universe simply doesn't allow overdrafts. Feynman often warned against asking why, questions that physics can't meaningfully answer. But he also insisted that when a rule appears unavoidable, it's worth asking what it's protecting. In this case, the infinite energy barrier protects consistency. It protects causality. It protects the idea that the universe can be described at all. If finite energy could produce infinite speed, physics would collapse under its own weight. Predictions would fail. Conservation laws would become optional. The fact that the equations refuse to allow this isn't a limitation, it's a stabilizing feature. There's also something quietly humbling here. Every star, every particle accelerator, every imaginable future technology is bound by the same rule. The universe doesn't care how clever you are. It doesn't care how determined you are. It only cares that the math remains self-consistent. And that realization has philosophical teeth. It suggests that progress isn't always about pushing harder. Sometimes it's about understanding where pushing stops making sense. The deepest breakthroughs don't come from breaking the rules, but from seeing why the rules exist in the first place. So when you hear that reaching light speed would take infinite energy, don't think of it as a dead end. Think of it as a signpost pointing inward, not outward, telling us that the ultimate limits of motion are really limits on how reality itself can remain coherent. And maybe the most powerful move we can make isn't to demand more energy, but to demand deeper understanding, because the universe doesn't yield to force, but it does yield to insight. At this stage, it becomes impossible to avoid a deeper distinction the universe makes, one that feels almost philosophical in how cleanly it's drawn. There are things that can reach the speed of light, and things that never will, and the dividing line between them is mass. Anything with mass is permanently anchored below light speed, not slowed by friction, not blocked by technology, but restrained by its very existence. Mass is not just weight or substance, it's inertia, resistance to change, the cost of being something rather than nothing. The moment an object has mass, it inherits a speed limit it can never escape. Only massless particles are allowed to move at light speed. The most familiar example is the photon, a particle of light itself. And the strange thing is, photons don't have a choice. They don't accelerate up to light speed. They are born moving at it. They exist only at that limit. This isn't a technical detail. It's a clue about how reality categorizes existence. If you have mass, you experience time. You have a before and an after. You age, you remember, you anticipate. Time flows for you because you are slower than light. But if you are massless, if you live exactly at light speed, time disappears. There is no waiting, no duration, no sequence of moments. This is not poetry. It's what the equations say. From the perspective of a photon, the moment it is emitted and the moment it is absorbed happen at the same instant. Across billions of years and unimaginable distances, no time passes at all. That alone should force us to rethink what we mean by motion, experience, and even existence. Mass, then, is not just a physical property. It's a commitment. It commits you to time. It commits you to causality. It commits you to living inside the slow, ordered unfolding of the universe. Light speed marks the boundary between participants in time and entities that exist outside it. Psychologically, this hits harder than most people expect. We like to imagine speed as freedom. The faster you go, the less constrained you are. But relativity flips that intuition upside down. Maximum speed belongs only to things that cannot experience, remember, or choose. The ultimate freedom from time comes at the cost of having no inner life at all. Mass is what gives you a story, and that reframes the speed of light yet again. It's not just a physical barrier, it's an existential one. It separates two modes of being. Below light speed, you are embedded in a narrative, Events happen to you, you change, you learn. Above it, if such a thing were possible, those concepts dissolve. This also explains why the universe is so uncompromising about the limit. Let massive objects reach light speed, and you blur the line between timeless entities and time-bound ones. You mix categories that the universe seems determined to keep distinct. Order breaks down, not because of drama, because the rules no longer know what applies to what. There's something quietly humbling here. We often talk about escaping our limits, transcending time, outrunning decay, breaking free of constraints. But physics suggests that those constraints are not punishments. They are the conditions that make meaning possible in the first place. You experience time because you have mass. You can act, choose, and reflect because you are slow enough to do so. Light speed isn't denying you something. It's granting you participation in the unfolding of reality. So the question isn't why we're held back. The question is whether we recognize the privilege of being held within. And maybe the most powerful realization of all is this: the very thing that stops us from reaching light speed is the same thing that allows us to live a life worth experiencing at all. By now it should be clear that the speed of light isn't protecting comfort or convenience. It's protecting something far more fragile: order. And the name we give to that order is causality, the idea that causes come before effects, that actions lead to consequences, that the universe tells its story in a coherent direction. That may sound obvious, almost trivial, but it's only obvious because the speed of light quietly enforces it everywhere, all the time. In everyday life, we never question causality. You flip a switch, then the light turns on. You speak, then someone hears you. The sequence feels inevitable. But physics tells us that this sequence depends entirely on how fast information can travel, and that speed is not arbitrary. If information could move faster than light, causality would stop being universal. Different observers would disagree not just about how things happened, but about what happened first. An effect could precede its cause in some frames of reference. The universe would lose its shared timeline. This is not philosophical speculation. It falls straight out of relativity. Once you allow faster-than-light signals, time ordering becomes inconsistent. The same event can be seen as occurring before or after another, depending on how you move. Logic fractures. Prediction collapses. Physics stops being predictive at all. This is why Albert Einstein was so insistent that the speed of light is absolute. He understood that it wasn't just about electromagnetism or optics. It was about safeguarding the very possibility of explanation. A universe without a universal speed limit is a universe where why questions lose their meaning. Think about the psychological consequences of that for a moment. We rely on causality not just for science, but for sanity, memory, responsibility, learning, planning. All of it assumes that the past is fixed and the future is open. If signals could outrun light, those assumptions would no longer hold consistently. The arrow of time would wobble. The speed of light acts like a referee, ensuring that everyone agrees on the basic sequence of events. You and I might disagree about how long something took or how far it traveled, but we will always agree on what could have influenced what. That shared structure is what allows communication, cooperation, and understanding to exist at all. Without that limit, the universe would still exist in some mathematical sense, but it would be hostile to meaning. You couldn't reliably trace effects back to causes. You couldn't trust explanations. Even the concept of responsibility would become ambiguous. How do you assign cause when time itself disagrees with you? Seen this way, the speed of light is not a constraint imposed on us. It's a constraint imposed on chaos. And this reframes a lot of our frustration with limits. We often imagine that removing constraints would make the universe more free, but physics keeps teaching us the opposite lesson. Remove the wrong constraint and you don't get freedom. You get incoherence. Causality is a delicate structure. It only works because information has a maximum speed. That speed defines the boundary between what can influence you and what cannot, between what is in your causal past and what is forever unreachable. It gives the universe a logical skeleton. This also explains why every attempt to seriously violate light speed runs into paradoxes rather than breakthroughs. Time travel contradictions, closed causal loops, messages arriving before they're sent. These aren't just science fiction tropes, they're warning signs, they're signals that you've pushed the equations past the point where meaning survives. The universe isn't being stubborn, it's being careful. And there's something quietly empowering in that realization. It means that when we seek understanding, we're not fighting against an arbitrary wall. We're learning the conditions under which understanding is even possible. The speed of light isn't blocking knowledge, it's enabling it. So when you think about that limit, don't see it as a ceiling pressing down on ambition. See it as a foundation holding everything else up. Because a universe where causes reliably lead to effects is a universe where learning, responsibility, and progress can exist at all, and protecting that may be the most important job the speed of light has. When all of this is taken together, something remarkable comes into focus. The speed of light stops looking like a technical constraint and starts looking like a definition. It doesn't just limit how fast things move, it defines what can exist in a meaningful way. We often ask why the universe is this way, as if it could just as easily have been different. Why this speed? Why this structure? Why these rules? But physics keeps pointing us toward a more unsettling possibility, that these rules are not add-ons to reality. They are reality. Change them too much and you don't get a different universe. You get no universe at all. This is where Richard Feynman's mindset becomes especially powerful. He was famously allergic to grand metaphysical claims. But he was also deeply respectful of what the equations were quietly telling us. And one of the things they seem to be telling us here is that light speed is not negotiable because it's doing too much work behind the scenes. It ties space and time together. It separates mass from masslessness. It enforces causality. It defines who experiences time and who does not. That's a lot of responsibility for a single number. When you ask what would happen if light speed were different, or if it could be broken, you quickly realize that the question eats itself. Faster than light motion doesn't just challenge physics, it dissolves the framework that makes physics possible. You lose consistent cause and effect. You lose a shared timeline. You lose the ability to say what influences what. Right? In other words, you lose reality as a coherent system. This is why the speed of light feels so final. Not because it's mysterious, but because it's foundational. It's like asking why the rules of logic don't allow contradictions to be true at the same time. You can imagine such a system, but you can't reason inside it. The moment everything is allowed, nothing makes sense. Light speed is the same kind of rule. It's not about stopping you, it's about making sure there's something worth stopping in. There's also a psychological shift that happens when you really absorb this. We tend to frame limits as enemies, barriers to progress, proof that the universe is indifferent or hostile to our ambit, ions. But the deeper lesson here is almost the opposite. The universe is constrained so that complexity, structure, and meaning can arise. You exist because the rules are tight, not because they're loose. If signals could travel infinitely fast, nothing would have time to become anything. No processes, no learning, no evolution, no thought. The world would collapse into a single, undifferentiated blur of cause and effect, happening all at once. The speed of light stretches reality out just enough for stories to unfold. And that reframes our role in the universe. We are not failed light-speed beings tragically stuck below some cosmic ceiling. We are time-bound participants in a universe that only works because that ceiling exists. Our slowness is not a flaw, it's a feature. Understanding this doesn't just change how you see physics, it changes how you see limits in general. Some limits aren't there to be broken. They're there to tell you where meaning lives. The trick isn't to smash into them blindly, but to learn what they're holding together. So when you think about the speed of light, don't think of it as the fastest thing in the universe. Think of it as the rule that makes the universe possible at all. And if there's a call to action hidden in all of this, it's a simple but demanding one. Stop asking how to outrun reality and start asking how deeply you're willing to understand it.